Hi everyone. So in the last session we have discussed about surface tension, the secondary properties of fluids. So in the surface tension we have discussed about what is the definition and what are all the conditions like the water droplet, liquid jet and the Euler bubble. So in this session we are going to continue with the numericals of surface tension. So the numerical, the first one, we can see here, the surface tension of water is in contact with air at 20 degrees Celsius. So we can see here the surface tension of water is contact with air. It is nothing but what you are having, the surface tension definition itself, it says that when there are two immiscible fluids are mixed together, we'll say that will be as surface tension. Means the surface of the fluid layer which is going to be acting under the tensile force, which is under tension. That's why we'll say that will be as that membrane will be worked as a tensional force. So we'll say that will be the surface having the surface tension. The same way here in this numericals we can see that the surface tension of water is in contact with air. So water and air, there are two fluids at 20 degrees Celsius is 0.0725 Newton per meter. The pressure inside the droplet of water is 0.02 Newton per centimeter square is greater than the outside pressure. Calculate the diameter of the droplet. So in this numerical, the pressure is given as well as the surface tension is given. We have to calculate what is the diameter of the droplet. What we can say the first condition of surface tension. So in this, first of all, before writing the solution, we have to write down the given data. So in the given data, the surface tension is given as 0.0725 Newton per meter. Then the pressure inside the water droplet is given as 0.02 Newton per centimeter square. So that says that 0.02 Newton per centimeter square, we should require all the parameters in terms of meter itself, the SI unit. So here it will become 0.02 into 10 power 4 because we know that 1 meter is equal to 100 centimeter. Then 1 meter square will become 100 centimeter by 100 centimeter. That will become 10 power 4 centimeter square. So if it is reverse, then it will become 0.02 into 10 power 4 Newton per meter square. Then the question is, we have to find out what is the diameter. And we know the equation from the surface tension of the first condition for water droplet. P is equal to 4 sigma by D. Sigma represents surface tension, D is the diameter and P is the pressure inside the water droplet. So now we have to calculate what is the diameter. So do the substitution. P's pressure is given 0.02 into 10 power 4 is equal to 4 into sigma is 0.0725 divided by D. Then the unknown is the diameter. Just do the cross multiplication. Then you get 4 into 0.0725 by 0.02 into 10 power 4. Then the diameter is 0.0145 meter or 1.45 millimeter. So this is the first numerical. In the second numerical, the pressure outside the droplet of water of diameter is 0.04 mm is 10.32 Newton per centimeter square, and in bracket it is mentioned as atmospheric pressure. Remember it. So now what you are having the same condition will be considered, that is the water droplet. Outside the water droplet there is an atmospheric pressure is present, that is 10.32 Newton per centimeter square. That is when it is contact with air, the atmospheric pressure is considered, that is 10.32 Newton per centimeter square. Remember here it is given in terms of centimeter square. Then we have to convert in terms of meter square. And the one more important thing to be remembered, when the numerical is given, sometimes they are going to, in surface tension they are going to mention it, consider the atmospheric pressure. Then if the value is given, then you can note down that. If it is not given, then you have to assume that the value will be as 10.32 Newton per centimeter square. Okay, this is the standard value of atmospheric pressure. Calculate the pressure within the droplet of water if the surface tension is given as 0.0725 Newton per meter. So in the previous problem directly we have to find out what is the diameter of the droplet, but in this problem diameter is given, pressure is given and the surface tension is given. Then which one is the unknown? So we know the equation P is equal to 4 sigma by D. P is given, sigma is given, D is given. Then which one is the unknown? But the thing is, here we have to find out the pressure inside within the droplet. It is nothing but inside pressure. But here it is given as the pressure outside the droplet of water, that is atmospheric pressure, is given. So first of all we should find out what is the pressure outside the droplet, then only it will be helps to find out the pressure inside the droplet. Okay, so diameter is 0.04 mm. Remember it, here it is millimeter and the pressure is centimeter. So all the units should be converted in terms of meters first. So 0.04 mm, we know 1 meter is equal to 1000 millimeter. So 0.04 by 1000, that is 0.04 into 10 power minus 3 meter. Then pressure outside, that is the atmospheric pressure, is 10.32 Newton per centimeter square or 10.32 into 10 power 4 Newton per meter square. Then surface tension is given as 0.0725 Newton per meter. Then P is equal to 4 sigma by D. 4 into 0.0725 by D is 0.04 into 10 power minus 3. Then we will get 7250 Newton per meter square. Or you can say 7250 will be as 0.725 Newton per centimeter square. So instead of Newton per meter square, you can convert in terms of Newton per centimeter square also. Because what the atmospheric pressure is given as 10.32 Newton per centimeter square. Then pressure inside the droplet of water, that is the pressure inside will be calculated by pressure outside plus atmospheric pressure. Outside the pressure is we have calculated 0.0725 plus atmospheric pressure is 10.32. Then add both, that is 11.045 Newton per centimeter square, or you can say 11,045 Newton per meter square. So this is the pressure inside the droplet. So these are all the two different numericals can be expected in surface tension. Whether they ask you to find out pressure inside the droplet, or they ask you to find out what is the pressure outside the droplet. So vice versa. So with respect to what is all these two numericals will be on water droplet. So try to solve it out with a hollow bubble, and one more condition is liquid jet. Okay. So in the next session we can discuss further about the next concept, that is the capillarity. So in this session we have discussed two different numericals that you have to practice. So then later on we can move with the hollow bubble and the liquid jet. Okay, just try to solve it. Thank you.